This presentation speaks to air system components. Below listed, I will speak to a simple explanation of their functions in the air system. Return air duct fan. The return air fan exists to return air from the conditioned zone and back to the air system. It allows for a good rate of ventilation and adequate air changes. Without the return air fan, the mixed air section could not function, and we could not make use of the seasonal free cooling provided by outside air. The total of building return air plus building exhaust air must not exceed the building supply air. If so, the building will be operating at a negative pressure relative to outside. This will allow for unconditioned outside air to enter the building through the building envelope. This is not desired when it is very hot or cold outside. It also results in unfiltered air entering the building. Mixed air components. The mixed air dampers consist of return, outside, and exhaust air dampers. These dampers are positioned using pneumatic or electric actuators. The mixed air section is usually controlled by sensing mixed air temperature and modulating the dampers to maintain a 60 Fahrenheit air temperature. On an increase in mixed air temperature, the outside dampers open, the return air dampers close, and the exhaust air dampers open. On a decrease in mixed air temperature, the reverse sequence occurs. The outside damper should full open before the cooling coil control valve begins to open. Minimum outside air dampers. Some air systems are equipped with a separate minimum outside air damper. When the air system is started, this damper opens and stays open while the air system is in operation. The filters exist to remove dust and dirt particles from the return and outside air streams. There are high-efficiency filters and low-efficiency filters, depending on the size of dirt particles it is desired to remove. The level of efficiency of filters is measured in percentage. The dirt and dust from the air is measured in microns. There may be high-efficiency bag filters, which are protected by lower-efficiency replaceable filters. The higher the efficiency of the filter, the more pressure drop there will be across the filters. The more pressure drop, the more fan horsepower is necessary to develop airflow across the filters. It is good operating procedure to measure pressure drop across clean filters, and when pressure drop increases approximately 0.3 inches water column, change them. The dirtier the filter, the less supply air will be developed. Preheat coil and heating coils. The air system may have a preheat coil as well as a heat coil in cold climates, especially for air systems which require a high percentage of minimum outside air. The preheat and heat coil have similar control configuration. A controller, sensing coil discharge air temperature, modulates the control valve which controls glycol flow through the coil. Most coil control configuration use a three-way control valve. When flow is not required through the coil, it is diverted to the return. The supply is to the bottom of the coil and return is from the top of the coil. There should be a glycol circuit balance valve in the control valve common return. The valve should be balanced to the maximum flow rate that the coil is designed for. It may be used for isolation purposes and is equipped with memory reset, which allows it to be opened only to the balance position after being closed. It is not unusual when a CBV is located at the discharge of a circulating pump that the pump be off before it can be fully closed. It has three uses: as an isolating valve, a flow measurement station, or a balancing valve. The purpose of the water balance is to ensure that coils closest to the discharge of the main glycol circulating pump do not allow too much supply glycol to pass to the return line. This would starve coils in air systems farther down the line. The air system discharge air temperature is limited to a predetermined high temperature. Should the air system shut down, the coil will open to provide full flow through the coil. Preheat and heating coil circulating pumps. These pumps circulate water or a water glycol mix through the preheat coil. In winter, when the air system is in operation, this pump is on and runs continuously. The cooling coil provides for cooling of the mixed air section. Chilled water is circulated through the cooling coil to provide the cooling effect. A controller sensing coil discharge air temperature modulates the control valve, which controls chilled water flow through the coil. Most control configurations use a two-way valve. When flow is not required, it is simply stopped. If the system has a two-way control, there must be a pressure differential bypass from the supply line to the return at the end of the line. There should be a CBV installed in the return chilled water line, and it serves the same purpose as explained for the preheat coil pump. The chilled water coil circulating pump circulates chilled water through the coil. The pump usually runs continuously when the air system is on. Direct expansion cooling system with a packaged condensing unit. Some smaller air systems make use of a direct expansion cooling system with a packaged condensing unit instead of a chilled water cooling coil. The operation of this system is explained in detail in the cooling section. The supply air fan delivers air to the building and provides for temperature control and proper ventilation for carbon dioxide control. Carbon dioxide is a result of the human breathing process. The natural occurring level of CO2 is about 400 parts per million, and if it increases to 600 to 700 parts per million, it can make people drowsy and inattentive. The existing standard is supply air should consist of a minimum of 20 cubic feet per minute of outside air for each occupant. Building supply air, which consists of outside air, return air, and must exceed the total of building return and exhaust air. It is required that the building be at least neutral or slightly positive pressure relative to outside. This will stop infiltration of unconditioned, unfiltered outside air into the building. This outside air will find its way through the building envelope, doors, and windows if the building is at a negative pressure relative to outside. On air system startup, the return fan should start before the supply fan. On shutdown, the supply fan should stop before the return fan. The supply air fan may be constant volume or variable air volume, depending on the system design. And last but not least is the humidifier. The humidifier adds moisture in the form of steam to the supply air. Usually the relative humidity of the return air is measured, and the amount of moisture added to the supply air is dependent on this measurement. A high limit controller with a sensor downstream of the steam grid limits humidification to no higher than a preset value. This will prevent saturation of the supply air. Thank you for listening. That's all for now.